We started with ray diagrams. No. Where did we stop? Terms and derivatives. Okay. The two types of mirrors we had discussed. Yeah. Okay. So, terms. Yeah. We had discussed what? Center of curvature. We discussed principal axis. Yes, so principal axis. What else? Principal focus. Then radius of curvature. Or center of curvature. Center of curvature. It is, what is the symbol? C. Okay. Then aperture. Okay. What else? Pole. Then focus. Focus. Then we had radius of curvature. Is everybody clear with this? And 7 by focal line. Okay. So pole, what's the symbol? The focus, capital R. Okay, radius of curvature, capital R. Focal length is small n. All right. So today we will learn about image formation. By concave mirror. Okay, so before discussing that, for image formation, we need to consider two rays. Okay, for image formation, any two rays from the following four rays must be considered. This you must keep in mind. Okay. So, for example, this is how we will draw the diagram for a image formation. We call it ray diagram, right? The ray diagram. So first you draw the mirror, then you mark the pole and the center of curvature. Okay. Then the principal axis, which will pass through P and P. This is the first step. Now, what are the two rays you will consider from the following four? So let's understand. One ray is the ray which is parallel to principal axis. Okay. So from where you get the parallel rays? From distant objects. When the object is very, very far away, say, yes, infinity. Like sun. Sun is at a remote distance, very far away. So that distance is infinity. What about a tree out of your window? That is also infinity because it is coming from far away, or a hill. Okay, that way. Now, what happens to a parallel ray after reflection? So how will you draw the reflected ray? What do you need to draw a reflected ray? Normal, perpendicular, right? So where is the perpendicular at this point? Radius. Very good. We had discussed this. Okay. So this is the angle of incidence, right? So now you can construct reflected ray with the same angle of incidence. So when you do the construction, you will find that this ray will pass through midpoint of C and P. Okay, and you will find that this. So when R is equal to I, this point which intersects the principal axis, we call that point as focus. Okay, and you can verify that this is always in the middle of C and P. Okay, so this is the first ray. I am giving this as ray number 1. What is the second ray? The complement of this. If any ray is incident along the focus, the reflected ray will be parallel to the principal axis. Okay, so that is the second ray. Instead of drawing separate diagrams, I'll draw the rays with different colors in the same time. So ray incident along focus after reflection will be parallel to principal axis. This is the second ray. So what about third ray? A ray which passes through center of curvature, or any ray which is incident along center of curvature. So what is center of curvature? What is the line joining center of curvature and any point on the mirror? It is always radius. So it is normal. So what if the ray is incident along the normal? Where will be the reflected ray go? It will retrace the same path, right? So it will go back. Okay. So this is your third ray. This was your second ray. What about the fourth ray? Now we don't have the color, different color. So what I will do is I'll use gray color. So any ray which is incident at pole. What should happen to this? So principal axis is also normal, right? This is angle of incidence. So the constructed ray, the angle of reflection will be on the other side of the principal axis. And angle will be same. So this way. So now we know what are the 4 rays. Okay. Because principal axis is also line joining C and P, which is normal. So out of these 4 rays, you have to consider only 2 rays as per convenience. Okay. So any 2 rays. So what do I do? So let's erase this. So now the topic follows: image formation by concave mirror. Now first one is object at infinity. Infinity is like sleeping it. It's simple. Now see how many references are there on the mirror. You have pole, then you have focus, then you have C, right? So what is the first object position? Infinity. Next object position will be beyond C. Then between C and F. Then at F. Then between F and Q. That's it. These are the at C as well. Yes, at C as well. So how many object positions? 1, 2, 3, 4, 5, 6. Okay, we'll see image formation for these 6 positions. And it is not a stress. You know what it is. The reference point ke pehle, on it, between it, on it, between it, like that. Okay. So 3 points. में कितना interval हो जाता है? 1, 2, 3. Then the 2 points, 5 and 1 infinity. Okay. So first, when the object is at infinity, let us see. What will you do? First, you draw the mirror. Right. Then mark the pole. Then you have center of curvature and principal axis. Then the midpoint also you mark now that we know. Okay, this is the first step. Now I told you whenever the object is at infinity, the rays will be parallel to principal axis. Okay. So let's say one is this. So it will go from focus. Now you need not draw normal every time. Now that you know how to draw the reflected ray, you know that from where the reflected ray passes. Take another ray from below principal axis because you need at least two rays for image formation. Now again, this also will go through focus. Okay. So now we have to find out what is the image position. Yes, image position at F. Nature of image. So what is happening to the reflected ray? Reflected rays are meeting at a point. So what is our definition of real image? When the reflected rays meet at a point, at that point, the real image will be formed. So it is real. And whenever it is real, it will be inverted. What about size? Highly diminished. Why do we say so? Or diminished to a point. Because at infinity, let us say the object is sun. Now we know sun size is so big, but when we take the image on a mirror and we reflect it, it is just a spot. Okay. So the size of the image is highly diminished as compared to the object size.
I'm supposed to draw A and B as well as the object.
Not in this case. This is the only exception. Next, yes, because the object is at infinity. We don't know what is its nature. So not in this case. Okay. So in your textbook, there will be 4 ray diagrams for concave and 4 ray diagrams for convex. Okay. So basically, it's elaboration or split version of this. Okay. So it's not required. You just understand it. What is required is this. Okay. So everybody will draw the ray diagram. Nobody will sit relaxed that I have understood. Kind of practice. Use freehand. It's okay. But I want everybody to draw that. Yes, that's one. Image formation by concave mirror. So the title should be ray diagram. This you need not. This is a concept diagram just for understanding. Now, which ray I have taken? I have taken ray 1. Okay. So I have taken ray 1 only. Okay. But I have taken two of ray 1 because only this is the ray possible in this case. Okay. That's why. Let me draw the second object position is object beyond C. Online student, can you see what I'm writing here?
Yes. Yes.
Object beyond C. So Yes. Let us say this is our object and we'll mark it as AB. Now we know what is the object. Okay. So object is labeled as AB. Is everybody done with this diagram? Okay, good. So what is the trick? Trick is, so when you're using your compass, okay, keep say 3 centimeter radius. So 3 centimeter mein 3 or 4 centimeter. So you draw the mirror, okay. Now you know C already, right? And draw a straight line. So in your notebook on the straight line only, you draw it like this. From there this way and from there this way. So now you have straight line for principal axis. Then if this was let us say 4 centimeter, at 2 centimeter you'll have F. You can keep the radius even so that you are able to divide it properly. So now you got C, F and P. Once you have this, then any object size, let's say 1.5, 2 centimeter. Okay, it should be smaller than the radius. Object size should be smaller than the radius. So that when you draw the parallel ray, it falls within the mirror aperture. Okay, these are some tricks. With practice, it will be very easy. So what you have to keep in mind is you have to draw this direction. This is the direction of incident ray, then the direction of reflected ray. If this is the direction, your ray diagram is incomplete. Okay, so both incident and reflected direction are required. Okay. So let's discuss the second one. Okay. Now see, A is the top position of the object, right? Now how many rays are coming out of the object? Only 2. For ray diagram, we take only 2. There are infinite rays. But we take only 2 because that is sufficient. And the rays are emanating from every point, infinite rays from every point. But we will consider only the top position, right? So now let's see what happens. So that those 2 rays will give us the position of the image of top position. Okay, let's see. So what are those 2 rays? The first ray parallel to principal axis. I take this ray. So after reflection, it will cross through focus. Okay. Now what about the second ray? Second ray, I will take this one. Because I know if it goes through focus, it will be reflected parallel to principal axis. Right? Let me go through. This is the direction of incident ray. This is the direction of reflected ray. So where are the 2 reflected rays meeting? This point. So now this is the image of the top position. Okay. Likewise, if we would have taken 2 rays from here, then we will get somewhere over here. So from different point, you will be able to reconstruct the whole image. So we don't do that. We only take the upper limit. Okay, and then we know that this is how the image will be formed. Understood? Yes. So we take only one reference, the top of the object. So this is the image. So how do we write the image now? B dash, A dash. So have I answered your question? So you have to mount the object and mount the image in this case. But here you don't have the object. Okay, that's one.
So an example of the was very need to draw an object like that diagram, right?
You have to.
Like for
For infinity, no. But for here,
Yeah.
yeah. Okay, so what is the image boosters? What I'll mention now? Position, nature, and size. So what is the position?
between and the same.
So between C and F. What is the nature?
Real and image.
Yes, what's the question? You sure? So, what is the page? 31. Where is it different? Which ray? I have taken which ray? I said any two of the four. Any two of the four. So you can draw the ray diagram using any two rays. So what is given in volume, that is also correct because they have taken a ray passing through C. Now see, I'll show you. If I would have taken from C, what is shown in the volume is this, and it will pass from here only. Because my drawing is not to the scale. Okay, what is shown in the volume is this way. So the mirror has to be slightly bigger. Both diagram are correct. Volume is considered ray passing through C. Okay. I'm coming to it. I only written position. Okay, so if you want, you can draw either the ray passing through C and returning. So the returning ray will intersect, meet at the same point. There is no difference in the position of image as well as image. So between C and F. Now, what is the nature of image? Why? Yes, the reflected rays are meeting at a point. What about the size? Diminished. In this case, only diminished. Because it is obvious, the object is bigger and image is smaller. That's why. So once you are using a compass and drawing the ray diagram to the scale, you will actually be able to verify. Yeah. So pre-hand, there may be some minor deviations. So I'm reading this part. I'll erase this one. And object at C. We have object at C. So try. So first ray always will be parallel to the principal axis. Almost all diagrams. What about second? You have is it correct? Not exact because this ray, my ray is bending. So you'll have to, with experience, manipulate a little bit. So this should fall exactly here. Okay. So C, A, B, B dash, A dash. Did I miss anything? Yes. The direction of reflected ray. Now this is. So what is happening when the object is at C, the image is at image at C itself. What is the nature? Size is distance. Okay, so what two rays we have taken? The first and the second in our concept diagram. Four. So you can argue with your teacher. Suppose in school, जैसा book में दिया है, फिर teacher बोलेगी नहीं 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 तुमने गलत draw किया, तो you can argue with your teacher, okay? Because that's okay. What I'm saying is, you got the point, but you need to be confident. कि वो any two rays book में लिखा हुआ है, you can take any two rays, okay? We'll see how you're able to solve numericals, because here will clear all your concepts regarding sign convention and sign convention. Is it covered? Okay, so we'll take up numericals also. Let's see if we can take it today. So fourth is object between. So you have to label it up. What I suggest is, first you don't put C and F. Okay? Complete the ray diagram, then label all this. Just leave the dots on the principal axis. Alphabets you fill in later on. Okay? So object between. So this may not be the case with all schools, I think. Only some schools have completed the ray objects, right? Not yet started. Not yet started. That's what I'm saying. No? So like it may not be same case for everybody. So we'll go by the order of the chapter. Object between C and F. C and F. Okay. So let's see. So not B. C. So object between C and F. You can place anywhere, okay? Between C and F. So first line will be always parallel. Reflected will come back to focus. Get off. Okay. Now what? So you can either take this one, okay, or you can, which one you can take? This also you can take, but that will not be very passing through F. Yes, that's the most easy, right? तो कुछ भी लेके करोगे तुम्हारा सेम जगह पे रहेगा. This is also right. आ रहा है क्या? ये गलत हो रहा है. The image should go beyond C. तो उसका प्रॉब्लम क्या हो रहा है कि the diagram is not to the scale. ठीक है? Image should be beyond C. See what happens as the object approaches the mirror, the image goes away from the mirror. And दूसरा क्या होता है? Size goes on increasing. Okay? तो C पे equal हो गया. Now it will be beyond C and magnified. What is this? The pattern. Okay, this is the pattern. So draw again. Now this is the. So we have this as C, F, E. This is what. ठीक है, तो image beyond C, अब बोल रहा है position. Position is beyond C. Then nature is and it is 90. ठीक है, so point in the first case of infinity when object at infinity, then second case it is diminished, then equal. Now it is like five. So fifth will be now at F. I had to silver coat my mirror, I forgot it. Yeah, please point out if I miss out or anything. Next is object as at F. So first completely clear. Right. But you have to school draw with pencil. Okay. Next is object at F. So again, one ray will be parallel to principal axis. Will pass through F only. तो यही से जाएगा. This is all. What about the other ray? So either you can take this, that is allowed, okay, or you can take it along the C. So your ray is going through along C. After reflection, it will come back. like this. Okay, so two rays is, in this case we have taken ray through C. Now tell me, where is the image? At infinity. Why? Because parallel rays will meet at infinity. Assume. I'll explain. So we said for image formation you need two rays. So from the top, right? One ray is parallel. After reflection, it will go through focus. Second ray is we are taking along the normal. So from C to this point, first you draw a dotted ray. So then your second ray is going along the normal. After reflection, it will retrace. Okay, so your ray is starting from here. After reflection, it is coming back. So where is it going to? Infinity. So what is the image position? At infinity. Image at infinity. Nature is nature's size is highly enlarged because these rays are, we are assuming will meet at infinity. So real and important. And this will be highly enlarged or highly magnified. Now this is opposite of first case. When object was at infinity, image was at focus. When the object was at focus, image is at infinity. So there is a pattern, opposite. Everyone with me? Now we have come to the last page for that. Or your object is between F and so one will be parallel. After reflection, it will pass through focus. Okay. The row C. So what is first to draw the reference line? This is the trick. Now you retrace. Okay, is everybody okay? C say first you draw the reference line for support. Then the reflected ray will pass back. Is it a parallel ray? It is diverging. So what do we do in case of diverging? We will try to find the point from where these rays are from where it is appearing to diverge from. And when we extend it backwards, so we will find a point behind the mirror. Okay, so then now here. So these rays are appearing to be diverging from this point. So let's say this is AB, this is F, right? So this is now A dash, A dash. Okay. So this side of the mirror is front. This is front of the mirror. This side is behind. What is the image position? Behind. So what is the nature of image? Virtual and direct. See, all real images were inverted. But this is up is the object and up is the image. Virtual and direct. What about size? Magnified. Okay. So we have learned about the nature of image position, and its size for various object position in case of concave mirror. All these cases you should remember at the back of your head. Okay. So then only you'll be able to verify whether you're doing right or wrong in the numerical problems. Okay. All 6 questions you have to remember. And remembering is very easy. The pattern is when the object is far away, image is point size, real and inverted. As the object approaches the mirror, the image size goes on away from focus, and the size goes on increasing. That's it. This is the trend. This trend continues till F. Then it reverses. After F, the image nature changes to virtual and direct. Okay, so it should be easy. With some practice, it will be easy for you. Anybody has any questions still here? Please ask. Next, we'll discuss about uses of concave mirror. So, where do we use concave mirror? Torches and searchlights, right? Okay, so torches and searchlights. So can somebody explain how in torch and searchlight or vehicle headlights? So let's say you have a concave mirror like this, right? And you have placed the bulb at focus. Let's say this is the bulb you have placed at focus. So when it illuminates, right? Then it will throw a parallel beam of focus. Right? So parallel beam of focus. When the source of light is at focus, you get a parallel. That's what is expected in torch or searchlights. Same is the case for vehicle headlights. Right? What else? Yes, dentist. Dentist also uses it, and shaving mirror. How? Explain these two.
then this shows that
Solar
they can either be magnified way.
Yeah, so like a spoon, okay, mirror like a spoon. So a small concave mirror fitted. So dentist will insert that mirror in the mouth, and that image he can see it. Because otherwise he can't put his eye in the mouth. So mirror is easy, right? That way. Then so something like this. Let's say we have a lecture here. So he inserts the mirror like this. And this is the tool. Its image will be मतलब tool ज़्यादा बड़ा होगा. ठीक है ना? So with some angle you'll be able to see that. Shaving mirror also, like if you have positioned yourself between focus and pole, then your face will be appearing bigger. So man was nobody is shaving right now, right? So these hairs you will be able to see whether it is properly cut or not. That way. Then solar furnaces. So solar furnaces. Furnaces are like giant stoves, you can call it. So in industry it is used. So if you have a giant concave mirror, the sunlight is coming here. Now it is opposite. So a parallel ray is coming. So the arrow, in this case, this is the arrow, right? In case of solar furnace, it is coming from sun and getting focused at one spot. So in that, if you have a coil through which water is running, okay, it will convert all that water into steam. And then that steam can be taken out to do various jobs. Like if it is given to the dynamo, it will start producing electricity. Okay, things like that. Or if they have kept something over here, it will be like it can be used for cooking food also. Anything. So that way. So in solar furnaces, as light concentrator. Okay, so these are some of the uses. Now let's look at image formation by convex mirror. And there are only two image positions, or two object positions. Formation by convex mirror. So first is object at infinity. Okay. So convex mirror is like this. Okay. So we have a hole here. Then let's draw principal axis. Of course, that C will be lying on the right side. So when the object is at infinity, the rays will be parallel to principal axis. Let's take two rays, one from above and one from below. So in case of concave mirror, rays which are coming parallel. Okay. So this diagram is still photo. Rays which are coming parallel, it will get focused at the focus point. But in this case, what will happen? It will go away from the focus instead of converging at the focus. Right? So let's say you have a focus of here. This ray will move away from the focus. Rightly so, because here this is the normal. So this is angle of incidence and this is angle of. So if you extend it backward, you will see that it's at focus. Got it? How we have drawn it? Incident ray is deflected away from the focus. So this is the focus. In this case also it will be deflected away from the focus. Like this. Right. Tell me, what is the image position in this case? So image at. So you need not draw this radius. I just have drawn it to explain how this reflected ray is made. So it is just opposite of concave mirror. Instead of getting converging at focus, now it is diverging from focus. It's that way. Okay, it is diverging away from focus. Okay. So now write down what is the position at focus. So the image position is at focus, and it is. What is the nature? Wait. What is the nature of the image? Correct. Virtual and upright. Why? So when you say at focus, you have to also write behind the mirror. For virtual cases, you have to write behind the mirror. Okay. Need not write because इसमें क्या behind ये है. So this side is always front. तो वो रहने दो behind अब लिखो at focus लिखो क्योंकि focus पे एक ही side है. That's good. Actually, it is correct because reflecting surface के पीछे वाले को behind बोलते हैं. This is reflecting at focus. ये नहीं लिखा तो भी चलेगा बट ठीक है. Then virtual and upright or direct. What about the size? Highly diminished or diminished to a point. Highly diminished. Correct. ठीक है. Then next is phase formation में second वाला क्या है? Now object is in front of the mirror. Is there any reference point remaining now? Nothing. So then between infinity and pole, what is the second object position? Between infinity and pole. So object between infinity and pole. So same technique. Now your object is here. Okay. And this is your test. Parallel ray. So it will be deflected away from M. So extend it backward. Up to S. What about the second ray in this case? Huh? A to P, that also is possible. Okay, and A to C is also possible. Right? A to P as well as A to C, both are possible. So if you take A to P, it will come here. And it will be reflected below the principal axis with the same angle. Then you have to take it backward. So now you see. So this is reflected from this point, and this is reflected from this point. These two diverging rays appear to come from this point. Okay, so this will be your. So this is A dash, A dash. Right, so this is one possibility. Is it the same diagram in your volume? Must have taken by C, through C. Now see, you can actually join this with C. See what happens. It will pass through the same point. So what happens is, if you had taken the second ray along C, right? So since it is normal, it will revert back. So these two rays will appear to be coming from the same point. So the thing is, either you take AP or you take towards AC, you will get the same result. Clear? So up to you. I mean, only two rays are required. This is also correct, but you decide what two rays you want. This is a correct diagram. Okay, so now what is the image position? Image is between pole and F. So image between E and F. Right? So what mistake did I do? This is a virtual, so it should be dotted. Okay, so virtual image will be dotted. So virtual and direct. Yes. Okay, what about size? Diminished. So if you see the comparison between image formation by concave mirror and by convex mirror. So in convex mirror, the image formed is virtual only. Okay. Whereas in concave mirror, it forms all kinds of images, real as well as virtual. Thus, it forms what? Magnified, same size, and diminished. This is always. Does it give you a magnified image? No. This should be clear here. Convex mirror image will always be diminished, either diminished to a point or just diminished. Okay, just keep this in mind. With that, let's discuss uses of convex mirrors. So which ray you want to keep? I think you keep C. That's easy. Now it is so simple. Take here, alright. Alright. Is it time? Yeah. Okay, we'll discuss in the next class. All.
Chapter 8.